In this video, we're going to look at several examples of evaluating indefinite integrals. So let's just jump into the first one. We're integrating 1 over x times the square root of x, which we could rewrite that as the integral of 1 over x to the 3/2, which is the integral of x to the negative 3/2. So all of that's algebra. All that's happening before we even integrate it. So now how do we integrate this? We're going to add 1 to the power, so negative 3/2 plus 1 is negative 1/2, and then divide by that new power. Dividing by negative 1/2 is the same as multiplying by negative 2 over 1. And then don't forget the plus c. So this is negative 2 over the square root of x plus c. That is the value of our integral. All right, let's look at the second one. Here we have x plus 1 times 3x minus 2. We're integrating that with respect to x, right? So that dx tells us the variable we're integrating with respect to. That is notation that is necessary when you are writing down integrals. That dx tells the reader that they are integrating this with respect to x and not some other variable. All right, so how are we going to integrate that? Now you might be tempted to say, oh, let's just integrate this, the x plus 1, and integrate the 3x minus 2. We'll integrate those separately, and then we'll just multiply them together. And that would be not correct. We can't do that. So we need to multiply that out first prior to the integral. Right? And so you're going to FOIL that out. So you'll get 3x squared plus 3x minus 2x. So that'll just give us plus x minus 2 dx. Don't forget that dx. That's notation that's necessary. And now we're going to integrate this. So the 3x squared, we can integrate that. We will add 1 to the power, so we get x to the third. Divide by the new power. And so that 3 is going to be divided by the 3 here, and so it's just going to go away. So it looks like a 1. Right? We typically don't write those 1s. The x is like an x to the first, so we add 1 to the power, so it's x squared. Divide by the new power. 2 will integrate to 2x, and then plus c. Excellent. All right, let's keep rolling. Here we have cosecant times cosecant x times sine x dx. So if we were to FOIL that out first, or distribute that cosecant, we have the integral of cosecant squared x plus cosecant x times sine x dx. What are we going to do with that? Well, cosecant squared, we do know how cosecant squared integrates. Cosecant squared integrates to negative cotangent x. What about this cosecant x times sine x? How are we going to deal with that? Well, what is cosecant x equal to? Well, cosecant x is 1 over sine x, right? So that's a rule that we have before. So 1 over sine x times sine x, this is just a funny looking 1. And what do you get when you integrate 1? Well, 1 is the derivative of just x. And then we'll tack on the plus c. So when we integrate that, we have to be really careful. We have to take it piece by piece. We have some trig stuff. We have lots of algebra that comes in, and all of our derivative integral rules. All right. Next up, we have 1 over 1 minus sine squared x, and we're integrating that with respect to x. So what are we going to do with that? Well, part of what makes this tricky is we have a 1 minus sine squared in the denominator. If it was just a sine squared, we could handle that, but it's not. So what could we do with that? Well, on that, we could use our Pythagorean identity. So 1 minus sine squared x, that is cosine squared x, right? So sine squared x plus cosine squared x is equal to 1. So if you were to move that sine squared x to the other side, you have cosine squared is 1 minus sine squared. And what is 1 over cosine? 1 over cosine is secant. So this is, we're just integrating secant squared x dx. Which secant squared, that integrates to, it is the derivative of tangent of x. Excellent. Now, I'm rolling through these pretty quick. Part of why I'm doing those quick is because we have those integral rules. And so you need to have those integration rules down. Otherwise, you're going to struggle. So it'll take some time to get them down, but you'll want to get those down. All right, here we have x plus 1 over square root of x dx. We're integrating that. So again, we might be tempted to integrate the top and bottom separately, but that is not allowed. That's not, we can't do that. So we need to get this, we can integrate sums separately or differences separately, but not products or quotients. So how might we deal with this? Well, this is x plus 1 over x to the 1/2. I'm just rewriting using rules of algebra. And we could write that as x over x to the 1/2 plus 1 over x to the 1/2 dx. So this is the integral of x to the 1/2 plus x to the negative 1/2 dx. Now we have it written as a sum of two functions. We can integrate those two functions separately. So x to the 1/2, we're going to add 1 to the power. So 1/2 plus 1 is 3/2. Divide by the new power. So dividing by 3/2 is the same as multiplying by 2/3. Plus x to the negative 1/2. If you add 1 to that power, you'll get positive 1/2. Divide by that new power. Put us 2, and then don't forget the plus c. And there are several examples of integrals, indefinite integrals. Come on back for our next video when we will look at some functions that have initial conditions and we're trying to find particular solutions. We will see you there.